Hi guys, in this video I will be covering the part 2 of the most common shapes that appear in the abstract reasoning section of the UCAT. Alright, so we've got our first set. So as soon as you see a set like this, what you should be able to see is intersections. So there's an intersection there, there. So as soon as you see a set like this, you should think of intersections. And what intersections usually relate to is the number of intersections, for example, the number of points that the shapes intersect at, the color, if that can change, and also the number of enclosed areas which the intersections will hold. So in this case, it can't be the number of intersections because, for example, in this we do not have any intersections, and it can't be enclosed areas either because we do not have any enclosed areas in this. So we can compare each box and see if there's any differences, and we can try and come up with a rule. So for example, if we look at this, we see that there's intersections. They overlap the shapes. So and we can also try to find other kind of rule. So we always spot a circle there. So if there's a circle in all of them, and we can see that the circle doesn't overlap with anything. And then if we look at the shapes that do overlap, we see that this circle is grey. In that case there, in that case there, and in there as well. And when they don't overlap, this circle is white. And that's the case with all of them. So that would be the rule for set A, is that if all shapes overlap, the circle will be grey. If no shapes overlap, the circle will be white. So if we look at set B, it should be the opposite or something different. So in that case, these shapes don't overlap, and we see that the circle is grey, which is the opposite of set A. And in this case, these shapes do overlap and the circle is white. And we can confirm that with all of them. So this is our rule. So set A, if all shapes overlap, grey circle. If no shapes overlap, white circle. And set B, if all shapes overlap, it's a white circle. And if no shapes overlap, it is a grey circle. So whenever you see overlaps, think of intersections, color, and the number of enclosed areas. Okay, so moving on to this shape, what you should see is there's a lot of same shapes. So in all of them, we have a rectangle, we have a star, and we have triangle, and also circles. In this might not be in all of them, but in most of them, these are the only 4 shapes that are available. So whenever we think of the same type of shapes, we should think of if they can have value. But in this case, they can't have value because we're not provided with the same number of shapes in each box. And then we can also think of positioning. So in this case, we would move on to positioning because we cannot give a value to any of them. So positioning. So if we look at the shapes individually, we will see that the rectangle is top, but then it moves to the second row, then the third, and I can't really say that they're in the same row. So I look at a different shape. So for example, triangle, I can see that second and third, second, first. I can't really come up with a rule here. And a star, well, that's in the fourth one, in the second one, and I won't be able to come up with a rule for a star and a circle either because they're all in different kind of areas. So what then I can do is look at relative positioning. So I can compare 2 shapes and see how they may be related. So for example, I can look at a rectangle and a triangle. I see that rectangle is above the triangle. Rectangle, there's no triangle in that, so it can't be the rule. And then I can compare rectangle and a star. So rectangle is above the star in this case, rectangle is above the star, rectangle above the star, rectangle above the star, and rectangle is above the star in all of them. So this would help me make my rule. So for set A, rectangle is always above the star. So we will be looking for something the opposite in set B. So star should be above the rectangle. Yes, that is the case. That is the case. That is the case in all of them. Just to note, this may not be the case in all of them. Sometimes it may be that, for example, the circle might be above the rectangle. It might be different, so that's why you need to check for set A and set B separately to make sure that this is the case. So we have our rule that rectangle is always above the star and for set A, and for set B, rectangle is always below star for set B. Alright, so in this set we can see a lot of different shapes. We can see two colors, white or black, and they are mostly different shapes. We can't really see the same type of shape in all of them, in all of the boxes. So when we see different shapes, what we should be thinking of is the number. I'll go through in more detail in a bit, and the number of sides as well, and if it's odd or odd versus even. It can be prime as well. Alright, so looking at these sets, what we can look at the total number of the shapes first. So in this case that'll be 4, in this case that'll be 4, 4, but we have 3 there, so this can't be the rule. And then what we can do is look at each color individually. So black versus white, so that's white, and we have 1 white but 3 blacks, and in this case we have 3 whites but 1 black. So we don't have the same number of color of each shape in each box. What now we can do is, because both of the numbers is odd, we can see if all of them will be odd. But then we find that this is even and the blacks is even as well, so this can't be the rule. So then we can look at the number of sides that each shape, each color has. So in this case for white we have 4 sides, it's a quadrilateral. For black we have 5 from the pentagon and 3 from the triangle, and that'll be 8, 9, 10, 11, 12, 13. So we have odd sides there. That's 1 for circle, 3 for triangle, 4, 5, 6. So we have 6 white and 5 for black there. So we're looking at odd for black right now and even for white. So we'll carry on to see if that rule carries on. And for black we see 1, 2, 3, 4, 5. So we still have 5, which is odd. And let's see if it's the same for white, if it's still even. We see 3, 4, 5, 6, 7, 8. So it's still even. So that will be my rule. So if I, so for A, we have even number of white sides and odd number of black sides. So let's see if the rule for set B will be the opposite of this. And we can start with this shape because it just seems easier to me, and we will see that there's 1, 4, and that 4 and 1 plus 3 will be, which will be 4, plus 5, 6, 7. So we have 7 white sides, and we have 2 black sides. So let's see if this rule carries on. So if we look at this shape, we have 12 sides and 2 there, so there's 14 black. And we have 1 circle there, 12 from the star, so that will be 13. So we do have a rule that for A, there's the number of white sides is even, and for number of black sides is odd, and for B, number of white sides is odd, and number of black sides is even. Alright, so for this set, we have a very simple set. We have only 2 shapes in each box, and whenever we have the same type of shape, what we think of is positioning first. So in this case there's only two shapes, so we can look at the relative positioning of both of them and compare how they are positioned to each other. So in this case we can look at the triangle. and what we see is the triangle is to the right of the white circle, and again in there as well, there as well, in there as well, and that will be the rule. So triangle is positioned to the right of the circle. But a lot of people will just stop there and move on, but this will catch a lot of people out. So what we also have to note is that the background, the lines in the background are moving from the left to the right diagonally. We can see that from there. But when we look at set B, well, the triangle will obviously be to the left of the circle, but the lines are going from the left to the right diagonally, top to bottom, instead of bottom to top, which was in set A. So make sure that even if you have looked at and found a rule, you keep looking to see if there's anything else. But that'll be our rule for set A, that triangle is to the right of circle, and there is a right diagonal background. And for B, triangle is to the left of circle, and there's a left diagonal background. Alright, so moving on. So again, what we can see is overlaps. So whenever we see overlaps, what we think of is intersections, and the number of intersections. If the color can change, if the color of anything changes with intersections, what we saw before, or if there's any enclosed areas that we can count. So for example, we can start with intersections, and so we can see there's 2, 3, 4 intersections in that case. 1, 2, 3, 4 intersections in that case. 1, 2, 3, 4 in that case. 1, 2, 3, 4. So we don't need to look at even and odd, because all of them are exactly 4. So we will, for set A, that will be our rule, that 4 points of intersections. So sometimes the set can be as simple as that. There's only 4 points of intersection. Sometimes you will find another set, another rule, but in this case there's only one rule. And for set B, there's 1, 2, 3, 4, 5, 6 intersections. Let's see if that's the case with all of them. 1, 2, 3, 4, 5, 6. So we do have 6 points of intersections for B. So that will be our rule. Just a point of notice, for these kind of intersections, sometimes what they'll do, in addition to the number of intersections, they might have how many shapes are intersecting. So for example, these are 3 there, 3 there, but because this is 2, this changes the whole thing. But if this was 3 as well, that will be our rule, and that will be in addition to our rule. So that will be 4 points of intersections and 3 shapes, but because we only have 2 shapes in that case, so the rule won't be included in that. So moving on, finally we have dominoes again. So remember, whenever you see dominoes, you compare them. So in that case, we don't have any vertical or horizontal, so we can just compare top to bottom. Remember, you can compare box to box, or you can compare inside the box. So in that case, we have 4 at the top, 3 at the bottom. So what we can think right now is that the even numbers at the top and the odd numbers at the bottom. Let's see if that's the case with all of them. 6, 1, yes. 4, 5, yes. 2, 3, yes. That is the case for... I'm only going to observe 4 because that should be enough. I don't want to waste my time. So that's my rule. So top half of domino is even, bottom half is odd.